Hello everyone, welcome back to the another session in Principles of Programming Languages. Successfully we completed 4th unit. Now today we'll be going to start the 5th unit. 5th unit is basically discussing about two different concepts. The first concept is about functional programming languages. So here we'll be going to talk about fundamentals of functional programming languages and the types of functional programming languages. So in general, there are many functional programming languages which works based upon mathematical functions and which are typeless languages which basically works with the functional, restrictions with functions. So these are what the languages what we do have, but we won't discuss all the languages. As far as syllabus is concerned, we are going to talk about Lisp and Schema, ML, Haskell. These 4 languages were there in the syllabus, and we also have the others chapter in the same 5th unit which is about case study of Python. So we will talk these 2 chapters in 5th unit. Now, so this video will be going to cover about what is functional programming languages and what are the fundamentals of functional programming languages. And my sincere advice is this video even will give you about the different kind of comparisons in between imperative languages and functional programming languages. So this is one of the question in the last year paper, comparisons in between imperative and functional programming languages. Maybe you don't find a separate slide to talk about the comparisons or differences. While I am going through with the video, you just notice what comparisons we were just having in the lecture. Now, so we'll be going to talk about functional programming languages. So basically, when I said functional programming language, you might have understood that the language which will have functions, correct? So all the languages will have a function, but when I say about functional programming languages, it's not what it contains, it's all what it base. That means whatever I do in the programming languages, that will be in terms of functions. Such kind of languages are defined as functional programming languages. So functional programming paradigm, which is based on mathematical functions, is the design basis of the most imperative, most non-imperative styles of languages. Now the first comparison here we have imperative languages. Mathematical functions or having a function is one of the feature. We don't write all kind of instructions in terms of functions. Whereas functional programming languages, we do have functions and we'll do the programming with respect to the functions or in terms of functions. Now let's say imperative languages instructions we'll write. If I wanted to perform addition of 2 numbers, then what I'll do, I just create a function name with add and I pass the parameter something like of 5, 7. As far as functional programming languages are considered, we'll take a function parentheses and we'll write function name with the parameters. Now, what you have to understand from this is imperative languages will have functions, non-imperative languages, that is what I am using here in the video, functional programming languages will use functions. The way how I have written is, you can notice, this is what functional parentheses, every instruction will start with functional parentheses. Now plus is what a function name, 5, 7 are the parameters to the function. So this is what the first difference in between imperative and non-imperative or else functional languages. Now, so from this you can have 2 kind of things, correct? Now just we'll write about the same. When I write something plus 5, 7, you can notice 2 things over here. The first is what the domain set, the second is what a range set. That's what we specified. A mathematical function is a mapping of members of one set called the domain set to another set called the range set. So mathematical functions what we are going to write in the FPL, functional programming languages, will have 2 kind of sets. One is domain set, the other one is range set. A function definition specifies the domain and range sets either explicitly or implicitly along with the mapping. The mapping is described by an expression or in some cases by a table. So one of the fundamental characteristic of mathematical functions is that the evaluation order of their mapping expressions is controlled by recursion and conditional statements or else expressions. Now the second comparison you can find here, second comparison is non-imperative languages, that means functional programming languages, will get controlled to that particular instructions what we were writing, that will controlled by recursion and by conditional expressions rather than by sequencing and iterative repetition that the common to the imperative languages. So this point will give you the other comparison. Imperative, it will get controlled by sequence and iterative, and non-imperative or functional programming languages will get controlled by recursion and conditional statements or expressions. And there are two kind of characteristics what are carried out by functional programming languages. The first characteristic is what? One of the fundamental characteristic of a mathematical functions is that the evaluation order of their mapping expression is controlled by recursion and conditional expression. So this point we covered there. The second imperative characteristic is what? Mathematical functions that because they have no side effects and cannot depend on external values, they always map a particular element to the domain to the same element of the range. Now I'll give an example. Let's see that if I wanted to calculate cube of a value, then I just write cube x into x into x. Now look at this, this is what a mathematical function I say, and this is what the domain set, this is what the range set. So we will not have any kind of external value over here, though you have some external value. External value is what? The value which will be supplied by the user later. So I am just taking here x, which I am saying it as an external value. Now I am passing the value over here. Fine. So this is what another characteristic how mathematical functions of these languages will work. Now we'll see the other things. Now this is what the example what we were mentioned. The example is what? Cube of x, k x into x into x, where x is the real number. So here k is what is defined as. We sound that k is what is defined as. That means cube of x is defined as x into x into x, where x is the real number. Now function definitions are often written as a function name followed by a list of parameters in parentheses. So this is what the mapping expression. Now the symbol k is used to mean is defined as the parameter x can represent any member of the domain set, but it is fixed to the represent one specific element during evaluation of the function expression. So we did not have any kind of value over here, we do have only explicit declaration. Now so you can pass this x value explicitly either by giving here 2.0. Here you can find the difference in between these two. This is what it is an explicit variable, but the value may not be given in the explicitly somewhere in the program or out runtime. So all this kind may not necessary. We'll just pass the value over here saying that something like of 2 over here. Now what does it mean? Though it is external value, we'll pass the value in the program itself. So this is other way of taking the value. We say it is implicit. Now and let's see a lambda expression. So a lambda expression basically is what? Nameless. When you don't know what kind of operation we were doing. So as far as the instruction is concerned, I know it is a cube operation. If I wanted to calculate something else where I do not sure what kind of function it is, we say it is a lambda function. Lambda is what? Nameless function. Fine. So we represent like this. A nameless function is represented with the lambda, and the syntax we write just like that. So this is about the function programming language basic fundamentals or basic features. Thank you all.